In addition to these two contact surfaces, product and non-product contact, there are also other surfaces defined, which we're not going to go into in any great detail, but there is a solution contact surface requirement for just cleaning solutions when you have certain systems where you're using air, like in a bag house or something like that. There are processing air contact surfaces and exhaust air contact surfaces that are often commonly defined in that type of equipment. So there are other surfaces contacted as well. The next section we're going to get into are the materials. These are to identify what materials can be used to fabricate the equipment. It is divided up into product contact surface materials. They have special requirements, obviously, for use in direct contact with the product. So we split it out between metals and non-metals. All of them have different characteristics and different requirements, particularly for corrosion resistance, usability, extractables on the non-metallic types of surface, the rubbers and the plastics and things like that. These things are defined what is appropriate. For the non-metals, there's generally a cross-reference back to 21 CFR Part 177. Materials also define non-product contact surfaces. We want these surfaces to be cleanable, but they're not quite as critical, obviously, as the product contact. So you might be allowed zinc-coated fittings or even some brass fittings on airlines. We don't want the standards to be so impractical that companies can't use off-the-shelf components for certain parts as long as they're far enough away from the product contact areas. Generally, the baseline requirement within 3A standards is 300 series stainless steel. That, I keep hitting the wrong button. That includes 301, 302, mostly into 304s, 316 stainless. Other metals can be used, and you'll see up here that it says that the shall be stainless steel or metal which under the conditions of intended use is at least as corrosion resistant as a number 304 stainless, non-toxic and non-absorbent. So you can use other more sophisticated metals for certain components if you need non-galling characteristics. There are plate heat exchangers made out with titanium plates for the corrosion resistance. So the baseline is generally stainless steel because that's most commonly used in the dairy industry, but you can go to other ones as long as they meet certain conditions. In the appendix, we do have a section for optional metal alloys that list a large number of commonly used other alloys that are used on valves, pistons, things like this that have different characteristics. So there is a listing in 3A. It's not all inclusive, but there are some examples there of what you can use. Within the materials sections, you'll have a section for rubber and rubber-like materials, which are covered by a 3A sanitary standard, and this will be one of your normative references. And the standards require that you list all of the applications, including coatings, where you're going to use these materials. 3A standards want the rubber and rubber-like and plastic materials where they want the applications listed. So if you're going to use rubber and rubber-like materials for gaskets, seals, scrapers, those applications should be listed. The steering committee and the working groups have migrated more to a very specific listing. Unfortunately, there are not lists of plastics and rubbers. The plastic industry has changed and changes so rapidly with alloys of plastics, laminations of plastics, all kinds of different formulations on plastics. We just couldn't keep up. And Lyle will touch on this, is that fabricators, when they get their TPVs, have to provide certifications that they meet food and drug requirements, CFR requirements, and the various 3A standards, either standard 18 for rubber or standard 20 for plastic materials. The 3A standards cover more environmental issues. How well does it stand up to butterfat? How well does it stand up to the cleaning solutions and acids and caustics that are commonly used in the food industry? So are these materials durable enough to be used? Other materials that can be used are carbon and ceramic materials, very commonly used on pump seals, rotary seals. Carbon seals are very common, but you can get into other more sophisticated ceramics. There are pH meters now that are 3A approved that have ceramic probes. There are other areas, there's ceramic membranes that are used in the membrane industry. So under special conditions, ceramics and carbon can be used, but here again, the specific applications have to be identified. As far as the non-product contact surfaces go, this bottom is really quite general. There's a lot of latitude that fabricators have on the use of non-products. We basically want them corrosion resistant, or they are a material that is rendered corrosion resistant. That means they could be plated, or they can be painted. Frames of a packaging machine or dry products filling machine, it's not uncommon for them to be epoxy painted, or there's lots of good surfaces. So they basically want them corrosion resistant. They should be relatively non-absorbent, durable, and cleanable. Parts that are removed for cleaning having both a product contact and a non-product contact surface shall not be painted. Obviously, you don't want to put a painted surface into a COP tank. And what is a surface that is product contact and non-product? Well, a pump head plate. The outside is non-product, the inside is product. So you wouldn't want a pump with a painted face. Then the next section we get into is the fabrication section, and this is the real guts of the standard. The other stuff is all kind of supplementary. This tells you the specific criteria of how to manufacture it in a sanitary design so that it can in fact be clean. And the goal is that equipment is to be designed to be 100% cleanable. And being clean is like being pregnant. It either is or it isn't. There might be differences in the range of soil. You can have something very slightly soiled, moderately soiled, put on a hazmat suit. There's only one clean. And some people will like to say, well, it's pretty clean, or it's, you know, partly clean. No, clean is clean. The design must preclude contamination of the product, so openings and access to the product, what can get into the product. You have to look at all of the areas where contaminants or adulterants might gain access to the product, so we wanted the product zones to be designed so they preclude all sources of contamination. As we've said a couple times already, fabrication to 3A criteria does not automatically imply compatibility with CIP. You can make either a manually cleaned item or a CIP cleaned item under the same standard. It covers both possibilities. Illustrations in standards and in the format and style manual often can convey concepts much more readily and much more easily than can the words. The old adage that a picture says 10,000 words is so very true. You can get the concept of what we're trying to say much more quickly through a drawing. But within the standards and within the format style manual, we call them illustrations. The reason we have gone to this wording is, again, so that there isn't a confusion with the fabricators, the engineers, the designers, because to them, drawings are very technical. They have tolerances, they have all kinds of notes and things, and so the intent is that what's in the standard are illustrations to show a concept. They are not intended to be engineering drawings that requires absolute adherence to just what's shown. So on product contact surfaces, the first thing is that surfaces, and it includes those that are fabricated, which means formed and bent pieces, welded and soldered joints, because soldering in certain applications is acceptable, sets the requirement shall be at least as smooth as a 32 micro-inch, 0.8 micrometer R sub A roughness average. The surfaces shall also be free of pits, folds, crevices, and cracks in the final fabricated form. Now there are two very important phrases in here. One is at least as smooth as. That phrase indicates that it does not require grinding and polishing. That's not a requirement. Grinding and polishing may, in fact, and in the practical world, be the only way a weld can meet this requirement. Welding usually needs some grinding and polishing, but not everything else, to get it into the free of pits, folds, crevices, and cracks in the final fabricated form. That phrasing, again, which is important to all because it speaks to not only the quality of welds and the fabrication techniques. If you break metal over the wrong kinds of dies, you may get gouges or scratches in the material, so it requires the fabricator to exercise some care, but it also opens it up for the use of a 2B surface. Sanitary tubing joints is an exception, and as long as it is welded in accordance with the AWS standard, which happens to be this cross-reference, and is free of pits, folds, crevices, and cracks and misalignments, the interior as welded surfaces don't have to be ground and polished. The standard was developed to assure that with the proper application of heat, backup gases, and rotation of the weld, if you're using either a mechanical welder or even a good hand welder, if they follow it and they follow the rules of the AWS standard, the welds on the inside of the pipe will be sufficient to clean without additional grinding and polishing. So it's a good thing we got a standard that allows us to make welds that will clean without additional preparation. However, it's always a good idea as inspectors on new installations or changes that you look at the welds that they provide before they polish the outsides. You can tell a great deal about a bad weld from the outside before they grind it and polish it and make it look nice. As far as permanent joints in metallic surfaces, surfaces shall be continuously welded. If the joint is not intended to ever come apart for any reason, excuse me, it should be continuously welded. We do allow in certain applications for press fits, force fits, or shrink fits, may be used for crevice-free permanent joints only when welding or soldering.